Hey everyone, my name is Ron. I've been working in software engineering for probably 15 years now, and I've been studying AI for at least since IBM Watson was on Jeopardy. I don't know if you guys remember that, but that's when I was like, AI is coming, and I started learning everything I could about it back then. Lived through the rise of transformer networks and GPT. It's been crazy, and I think we're still at the beginning. I always tell people we're at the Wright brothers moment still in AI. There's going to be a lot coming in the next couple of years. But a couple months ago, it was a little bit popular in tech media. You might have seen Apple release their model that they called Fast VLM as a research project. Um, and what they claimed was you know if you have an iPhone or you have a Mac, it's using their MLX framework. Apple has a machine learning compute package that they call MLX. It's very similar to like PyTorch and TensorFlow, but they took a vision language model, I think based on Qwen vision, and then they optimized the encoder part of it. And what their claim to fame was is that you could get sub-second latency between the model processing an image and getting an output. And I was just curious, is this possible? What are they doing here? Uh-oh. Let's see. NCSU guest. So I went, to their GitHub and downloaded it, and just to see what it could do. And I'm going to talk a little bit about that here today. Okay, yeah. So this is their GitHub. So I'll go ahead and just run what this is more or less their Git package without any modifications to their model code at all. And what I found was basically 1 out of 10 times would it actually. So it's gonna takes a second. The model's about 8 gigs to load up, but about 1 out of 10 times it will actually correctly do the task that you want it to do. So, and then that's where I started. Well, what's going on with this model? I kind of built all of these things to adjust the temperature and top P. I have a little debug here that shows just what the raw model output is, and it doesn't really matter. You can't, whatever it output, it just outputs gibberish, and maybe 1 out of 10 times it'll do something, useful. So to me, this is a quantized model. This is their medium model. On the small model, I was getting like 1 second latency. And this is an M1 Pro. This is about a 5-year-old laptop at this point, which is really good actually for what the model is doing for what on the back end. So I suspect it's either undertrained or when they quantized it, they just didn't do the. You have to calibrate a model when you quantize it to make sure the weights kind of get back into to where they need to be. So the checkpoints they release are kind of useless. But about a month after Apple released this Fast VLM, another company released a model called Intern VL3 that was a different competing vision language model, and they had an small one, 2 billion parameters, 8 billion parameters, up to 30 billion parameters. But their 8 billion parameter model they claimed was as good as like GPT-4 not class of things. I was like, okay, let me get that one here, and I want to see how does that, because 8 billion parameters, it should be able to run on your computers, your Macs, even the newest iPhone has enough RAM at 12 gigabyte. If you get this iPhone 17, you can run these 8 billion parameters models. So I started working on that, but I couldn't get, the model loads and it runs, but it doesn't quite. There's some kind of bug in the Swift code, but I do have another demo in the Python code that I can show you. And the Python code is also using Apple's MLX framework. So in theory, once I can get it working in Swift, it should work identically to Python. And I think I'm actually really close, probably another couple days, and I'll put it up on GitHub. And I think it'll be the first project where Intern VL3 is running on an iPhone. But for now, I'll just run it on the laptop here. Yeah.
Does it basically encode with fast VLM and then decode with like a large language model like Qwen or like other kind of like open source models and stuff like that? And can you change that at all?
Yes, that's a great question actually. So that's what Apple did. That's why Apple did this open source model. If you read their documentation, there's like it's model agnostic, their process. So what they did was when you're talking about a VLM, it has the text input, which is text or decoder only, and then you have your image input, which has to be encoded because the image is raw data. So what Apple did was take the image encoder, break it out into a core ML project, and then they trained the core ML project to be optimized to run on Apple's platforms. So what you could do is take their process, any vision language model, rip out the vision encoder, optimize it in Core LM, and then get these very low latency inferences for any model. And I'm sure Apple's going to release that in the next iOS version. They're going to release some version of this that does that. But yeah, it's model agnostic. That was what the main brunt of the research is. So this in the path here is intern VL3. So one thing I was curious about, when IBM Watson was on Jeopardy, I think they had an 8,000 CPU core compute cluster that they were using to do a map reduce on their entire database for every question that the robot had to answer. It's like, okay, how good are LLMs now with doing that? So this is just intern VL3. It takes about 10 seconds or so for the process. It's getting the raw image input, and the thing with vision language models is that they sort of think in vision. They're not just language models that can read. They kind of interpret, everything that they do kind of in the visual space. So when they see like a picture like this, it's not like it's transcribing it and then answering it. It's actually it's turning this image directly into concepts similar to like what you would do when you're reading a book. You're not reading every letter and then thinking the word. Your brain just knows these words mean, these concepts. So let's see. Okay, it's still running, it looks like. So in testing, it normally takes about 10 seconds, but I'm out of that. It's taking a little longer this time. Oh, it's because this one's still open. It's sucking up all my RAM. Okay, so yep, it's running. It thinks
what is unfriend?
It thinks the answer was unfriend. So it got this one wrong, which it for some reason it's gotten this one wrong every time. Does anyone know what the answer is? Probably. I think it's cromulent. Yeah, I think that's what it is, but I couldn't get the model to do that. So let's try this one. It's gotten this one wrong a couple times too. I thought the audio would come through, but it is reading out the answer, but I don't think you guys can hear it from where you're at. So, yeah, this clue refers to the person who's won the title, matching the starter and who played in the leading role. The correct character is who was Cole Porter. What is Cole Porter? I don't know if that's the right
what
answer.
What is Cole Porter?
That may
Cole Porter won Oscars for Best Original Song for Night and Day, 1932.
So this is actually a really good model when it works correctly. It can adapt to any size image. It has really good knowledge. So I think it's based on a Qwen 3 based large language model, and it's really great for vision and even just general purpose LLM stuff. And it can run basically on phones now. So if you go back to 2011, I think when IBM Watson was on Jeopardy, to now do your Moore's Law, 8,000 cores actually does boil down to somewhere around 6 cores, which is what are in the phones now. So it's pretty wild. This one used 9 gigabytes of memory. The image prompt here, so this image for Jeopardy was the equivalent of 3,400 text tokens. And to process the text tokens, the model was running at about 60 tokens per second. And then the generation of the answer that it gave, which was 60 tokens, which includes the explanation and answer, it does it on this 5-year-old laptop at about 9 tokens per second. And this model was just released. This is not with any KV caches or anything like that. So you can imagine about another 6 months, you'll have this model that, you could be watching Jeopardy with your phone and it'll answer before the human contestants. And that's just, 14 years of progress. Something else kind of related to this, I know I'm a little bit over time here, but I would definitely encourage you all to look at this paper that was released last week. So VO3, which is, if you've heard about that, it's Google's video model. It's not just, everyone's like, oh, it's generating videos, or you can make a TikTok, but what it actually is kind of a world model. It's a system that can simulate essentially, any question that you ask it in kind of a physical space. So what Google DeepMind, they just released this paper last week. Just look it up. But they tested the VO3, what people are thinking of as a video model, against all of these different reasoning scenarios, and they found that it is reasoning in the visual kind of space. And I think that's really kind of profound if you think about it. There's a story, I don't know if it's true, where someone asked Albert Einstein, "Hey, how did you think about theory of relativity?" And he said, "Oh, I imagined myself writing a photon, writing on a photon." And that's kind of what these next generation of models can do, is they can kind of conceptualize in this physical, visual, volumetric space. And this paper kind of goes into that. So you should expect in the next year, this is going to lead to an explosion of new types of capabilities and new models. And I think probably every model in a couple of years will be this style of world model. So yeah. And I think a lot of them will run on your phones too, so you don't have to worry about the power usage and the water and all the stuff that you read about. So, but any questions?
Besides cheating at Jeopardy, what are some of the practical aspects? I can think of a few, but what were you thinking? Practical applications for cheating on others.
Yeah, no. Yeah, that's a good question. So, I mean, I like I mentioned, I've been interested in AI for really my entire life, but deeply in the past 10 years. And I just like, my interest is that these new capabilities, when models are built from the ground up with vision and audio and spatial awareness, the ability to answer questions is going to be much better. When you talk about hallucinations and accuracy, the models are going to just get better. So that's what I'm kind of thinking of, is I'm just excited that these new capabilities are on the horizon, and you can run them on your cell phone. I think I'm a big fan of edge AI. I think in the future, everyone will be using compute on their own devices because, it's privacy and all that stuff. So I'm just excited that the capabilities are growing.